Hello everyone. So here go on the place and select text, and now you can write down what you are going to do. So we have opened this multisim and now we are going to write what project we are going to do. So we are going to create a design for full subtractor using NI multisim, and I have written here. You can type your name, otherwise your college student ID also over here if you are making any project for your college. So now just go to place and then select component, and here you can select all the component. Like I have selected this green probe and this red probe. These two will work like output. Now I have to give supply, so I have selected VCC and I will have to give a ground also. Here I have taken the ground. Now I will select switches. So I can type directly SPDT, single pole double terminal switches also. Otherwise you can go inside the option switch and you can select directly the switches also. So it is not showing. Let me select all families. Yeah, now it is here. So I will have to flip it horizontally first. Rotate it horizontally, and then I need two more copies, so I just have to do copy and paste, Control C and Control V, and here I have three switches. Now let me place them in some good manners, so it should be look visible to you very clearly. So before designing this circuit, you should have a picture that what you are going to do. We just have to select the component. You have to put this component here over here. Now we have to do wiring. For the wiring, you just have to click on the end of any component and you can drag it up to second component where you can do wiring. Like you see here, I just clicked and I dragged, and then clicked and dragged, and again click on this component switch and then I dragged, and here I have done this wiring. Now again I'm going to connect the ground for this switches. So there are open terminal I have selected in power. So when I will press the switch, so switch will get the power and switch will be activated. And the closed terminal I have selected in the ground. It seems okay now. Now I should go to select more component. Like for full subtractor, I need two XOR gate, two AND gate, two NOT gate, and one OR gate. So place component, and here I can go in the option 7 4. Here you can see that there are a picture of gates also. So I go in this 6 volt option, 74SC 6 volt, and here I got AND gate. So I need two AND gate. So again I will click on the B, A and B. I have a two AND gate. And then I need more gates. Let's see what I get next. All the gates I will go inside this family only, this group only. So now I have a NOT gate. Again NOT gate, I need two quantities. So A and B I have taken. Again, okay, select cancel, and again I have to select two more gates, XOR, otherwise one OR gate. So here I need XOR gate. Yeah, that should be from the bottom. Yeah, I got XOR gate. So again I need two XOR gate. Yeah, here it is. Now I need OR gate. So that one also I will get over here only. Where it is? Yes, this one. So there are written also the name of the gate in the detail. While selecting, we can see. Now we need to place it just like the circuit diagram, and if we have to do the wiring for this component, you just have to follow the circuit. If you don't have the circuit, so just go in last in the video and take a screenshot and keep for reference. So I'm constructing these gates. So I have this XOR gate, and this XOR gate will have a two input. So first input will come from the S1 and second input will come from the S2. And this one is NOT gate. I'm just following the circuit. Okay, so any component I can connect. It is just similar to the wiring. Like when you do the wiring, there's no matter which wire you are going to connect first. So anywhere we can connect first. We just have to follow the correct circuit. We have to do the correct wiring. So now I have to give input for this gates, which will be come from the second input S2. Yeah. So this half subtractor have been ready almost. And now the output of this first XOR gate will go to second XOR gate. And again I have to create this XOR gate, then NOT gate, and then AND gate. So input of the NOT gate will come from this. We just have to follow the wiring and we have to do this wiring. We can move these labels also. This is not required, but I'm just moving this label so it can be visible to you. This OR gate will be in the last. It will generate output, borrow output. And the differences will be come from this upper XOR gate. That will be known as a difference output. So I have connected this wiring. This is little bit time taking, but when you have a habit, it will go very smoothly. I should remove the label of these components so the circuit will be visible to you very clearly. Yeah, like this. Now it is looking much better. So I should remove all the labels from all the gates. So this wiring and this picture will be visible very clear to you. Yeah, now it looks much better. Very beautiful. So in the similar way, I am going to remove all the labels. Okay, so I have removed, but I should keep the name of the switches. So I can tell you that which switch I'm going to open, because there are three switches and one by one we have to give input. So I should keep the name S1, S2, S3. Even this name is not so good. I will change, but first I should do the wiring. So there are little bit wirings are remaining. I should complete first. This is again intersection, doing intersection too much. Let me drag it a little bit so you can select and delete if you want to delete any wiring. Like this wiring is doing too much problem. Okay, I can connect it directly also. Why I should go do too much things? Yeah, now it looks much better. So the circuit is almost done. Only output is remaining. So yeah, this value is not important. 2.5. Now it is good. You can do in the beginning before copy also, but there are not too much component, so it is again okay. We should change the name of the label. So in case you are going to submit your project in your college or school, so it will create some more good impact. Like this x1 is actually borrow out. No, I cannot put a space, so I can give an underscore. Yeah, now this is borrow out, and this one should be differences. I should change the name of S1, S2, S3 also. It should be input A, input B, and input C. Okay, I am going to change the name A input, B input, and C input, but just remember that C input is actually borrow in. C input. Yeah, okay. So here we go. Our circuit is almost ready for the testing and trial. So this is full subtractor using NI MultiSim. And now we are going to run this circuit and we are going to verify with our truth table. So let me set it a little bit. Okay, now let's run. So we can check if we give only third input, which is known as a borrow. So look, all outputs are high according to truth table. If we give only second input, so again all output will be high. See, now I'm going to final input, like all inputs should be high, so all outputs will be high according to truth table. Now I'm going to check it. For yourself, you can check all the inputs through the truth table, but I am just going to check the last one only. You see, it is working just similar to the truth table. Now I'm going to make the high all the inputs. Yeah, and here all outputs are high. So it is working perfectly. Thank you very much.